Today we're going to review what trigonometry is. Trigonometry studies the relationship between angles and sides of a triangle, the measurements and all the in between of them. And it studies six basic functions, which are sine, cosine, tangent, cotangent, secant, and cosecant.
We will focus on those problems that require precise measurements of the distances between two or more points. This topic has applications in a lot of areas, which include, for example, localization, GPS, also architecture, and geography, like in Google Maps. It turns out that knowing only two basic formulas, which are easy to explain, we only need to have a piece of the information contained in a triangle, as we have said in the introduction, as for example this thing, and we will be able, using these formulas, which are all of sines and cosines, to compute or to calculate these two values and this last one.
It's important to understand the six basic functions, the six trigonometric functions, even though they are based on the unit circle or in the triangle. But for making it more simple, we're only going to use the three basic ones, which are sine, cosine, and tangent.
Those who do not remember these definitions, we can understand sine and cosine as a pair of coordinates. So we have an angle x here, then the x coordinate is going to be cosine of x, and the y coordinate is going to be sine of x, where the radio of this circle is 1. This is true because if we consider the triangular definition, if we have x, and so this measures, let's say, A, B, and C, we have that cosine is A divided by C, sine is B divided by C, and the tangent is B divided by A. Right? In the circle illustration, we can understand the tangent as the inclination of this line. So this will mark the value of the tangent.
The tool that we possess in order to solve trigonometric problems is the law of sines. The law of sines establishes a relationship between the angles and the sides of a triangle. For example, in a triangle we have, for example, A, alpha, and B. If we follow this rule, we can obtain the rest of the data because we possess three values, and we could get the other ones. We also have the law of cosines. The law of cosines is pretty simple to the other one. It establishes again a relationship between the angles and the sides, but in this case we can understand this whole thing as a generalized type of Pythagoras theorem in order to solve this triangle.
The concept is the one of angles in parallel lines. This is useful because it allows us to identify similar triangles and to trespass trigonometric functions. So, for example, we have two parallel lines, which are lines that never meet. We're going to have these angles are going to be equal, and the same will be these ones. And these other four are also going to be equal. Interesting example of the application of this concept is the one that Eratosthenes used a long time ago to measure the circumference of the Earth. So how he did it? Well, he looked at an ancient, at some point of the year, the shadow of the sun was none. And at the same time, in Alexandria, there was a shadow. So he assumed that light beams were practically parallel, since we are far, far away from the sun. And what he did was that since these lines are parallel, then this angle equals this angle. And, well, he could measure this angle by assuming this was a flat piece of air, and therefore by assuming this was a 90-degree angle. And by using trigonometry, this is measuring this these two distances, let's say A and B, he could calculate this angle and therefore this one, and he just needed to know this distance, which then he multiplied for to calculate the complete measure of the circumference of the Earth. His calculations were very precise for the time he made them, and they are great because he did not use any advanced tool as the ones we have right now. This was a breakthrough in that time.
Another problem would look like, we have for example here Annie and Bert, which we know that they are that there is a distance of 10 kilometers between them, and they want to know how far is the island from Bert. Bert right here, and they want to know how far is this length. So this problem is expressed right here. We have the value of two angles, which are 30 degrees and 80 degrees, and of course the 10 kilometers. By angles, we can determine that this angle is equal to 70 degrees, which will help us in the problem that we will solve by the law of sines. If we use law of sines, we could substitute the values that we have and just leave the one that we don't have in order to get it. We have that if we express it and we simplify it, it's like this. So if we put these values in a calculator, the approximate value of the result would be 5.32 kilometers. So the x is equal to 5.32.